Hello, this is Dr. Strickland. In this video, we will investigate the nomenclature of carboxylic acids and carboxylic acid derivatives. Take a minute to read through these student learning objectives. These are the things you should be able to do by the end of this video so that you're ready for the more difficult things we will do together in class. Now, carboxylic acids we have some familiarity with. Carboxylic acid derivatives are related to carboxylic acids, and this is how. Each one can be converted into the corresponding carboxylic acid by means of a hydrolysis reaction. So we'll talk about hydrolysis reactions and we'll see some of these. But that is how a type of, a group of compounds gets classified as a carboxylic acid derivative. So we're going to go through starting with this carboxylic acid right here and see how these other compounds have names as well as structures that are related to this. So you see here, I'm going to number this parent. This guy is called pentanoic acid. And the carboxylic acid group, this guy right here. One thing I want you to see is that this carbon here is not only part of the functional group, but is also the first carbon in the parent. And that's typical of carboxylic acid derivatives. So we're going to note both the name of the specific compound and the group to which it belongs. All right, so if you had an alkane that had 5 carbons, put that down here, what would the name of this be? We can number it the same. I'm going to give you a few, and then I'm going to ask you to write their names. How about this guy? And then we'll do one more. Let's do let me make sure I've got my number of carbons correct. All right, 5 carbons in each case. All right, so I'd like you to write me the systematic name for each one of these 3 compounds. Okay. Pause the video and do that and come on back. All right, welcome back. So, this one is pentane. It's an alkane, and this is pentene. It's an alkene, and this is pentanol, an alcohol. And in each case, we've got the same parent. And let's stop short of the suffix there, and you see it right there. Okay. Alkene, alkene, alcohol. We've seen these kinds of parents with alkynes and with amines. So with all of them, you know something about the nomenclature that goes with each kind of compounds here. And so we're just adding some to what you already know. Okay. All right, so let's go on up to the top. All right, so this part of the name of pentanoic acid is what tells you what the functional group is. So when we come up here to this guy at the top, this is the most reactive kind of carboxylic acid derivative. And it's called an acyl chloride. And so we can do the numbers. And I set them up so that they would have the same numbers. So this guy is pentanoyl chloride. All right, so I'm going to put its type over here and then its name out to the right. And I want you to see, let me do a few and then we'll compare them. This is an anhydride. Let's do a little coloring in here of the functional group itself. This is a symmetrical anhydride. Sometimes you will see them called, instead of just anhydride, sometimes you'll see them called carboxylic acid anhydrides, as opposed to phosphoric acid anhydrides. And it's symmetrical because the alkyl portion out to the left here and out to the right are identical. So if they're not identical, this is an unsymmetrical anhydride. Oops, sorry, that should be an N. Same functional group, but different alkyl groups. And then this guy here, we've seen some before. This is an ester. Okay, so we've got functional group right here. And you'll see the numbering is very much the same. It starts with the carbonyl carbon. That's the sp2 hybridized carbon that's involved in the double bond. And it's the first carbon of the parent. With the anhydrides, generally what you do is you have to number both sides. So I'm going to do 1 prime, 2 prime, 3 prime over here, just so we can count carbons. 1, 2, 3, 4, 5. 1 prime, 2 prime, 3 prime, 4 prime, 5 prime. Okay. So with a symmetrical anhydride, if both of these alkyl groups are the same, then you only have to say the name of this portion one time. And so since we've got 5 carbons here, this is pentanoic anhydride. If it's an unsymmetrical anhydride, then you have to get the names of these 2 different halves and put them in alphabetical order. So propanoic is going to come before pentanoic. So it's not because it has fewer carbons. It's because it has fewer, it's because it comes first in the alphabet. Oh, so I'm doing that wrong. Should be pentanoic. Pentanoic, and then propanoic anhydride. Because PE comes before PR. All right, so down here with the esters, the name of this group comes first in the name. In this case, it's a methyl group. It could be lots of other things. So this is methyl pentanoate. Okay. So you see in every case, we've got some similar things. But we've also got some things that are different. Okay, so what you're going to find is that with a lot of the information in this chapter, it's related, but not identical. So in order to lessen the load of, oh my goodness, how much do I need to learn? I want you to be able to see these similarities, okay, as well as the differences. You do have to deal with the differences, but there are a decent number of similarities. All right, so come on down here. Let's look at these other ones. This is actually a carboxylate ion. It's a sodium salt. The carboxylate anion. So the conjugate base of the carboxylic acid. And in this case, this is going to be sodium pentanoate. So much like with esters, the thing that's connected to the oxygen goes first, and then the rest of the name is the same. So that's an interesting thing to keep up with. Or maybe we'll stick that in there with that. So esters and carboxylate ions have some similarities in their names. Then with amines, you can have two hydrogens attached to this nitrogen, two alkyl groups, or one of each. So I just did a couple of different ones. This is an unsubstituted amide because there are no alkyl groups attached to that nitrogen. So because it's just got hydrogens there, it's called unsubstituted. And this one here is a monosubstituted amide. And if you had two alkyl groups attached to that nitrogen, it would be a disubstituted amide. So count the carbons. And so this one here is called pentanamide. Okay, so make sure that you see that you have to keep that final AN of the parent name. Okay. AN and then AM for pentanamide. If you have something attached to the nitrogen, then it comes first, just like we saw with esters or with carboxylate salts. This guy is N-methyl, and then a space pentanamide. All right, so let's color in the functional group and do that. And then the parent and how it's related to the carboxylic acid, it's pretty easy to see. And it doesn't take too much of a stretch to see how each one of these carboxylic acid derivatives is related to that. But this last one, the nitrile, this is a little bit like, I don't know that I would have thought this initially, but the reason that this gets to be a carboxylic acid derivative is that if it goes through a hydrolysis reaction, it forms the corresponding carboxylic acid. So the functional group is actually right here, and like with the other ones, this carbon is not only part of the functional group, but also the first carbon of the parent. This is called a nitrile. And the name is pentane nitrile, and we're going to keep the E on that parent because the first letter of the functional group name is a consonant. Okay. All right. So that is the story on the nomenclature of carboxylic acids and their derivatives. Oh, one more thing before you go. I said that the acyl chloride was the most reactive of the carboxylic acid derivatives. And then that reactivity decreases as you go down here, so that when we get to the bottom, the nitrile is the least reactive of these carboxylic acid derivatives, and that'll come up down the road a little bit. All right, so if you have any questions, please send them to me.